In my last video, I did some test prints on this Ender-5 Pro and compared it to other Cartesian-style printers like the CR6SE. The Ender-5 Pro printed slightly better than the CR6SE in both prints. I would say this could be the best quality Creality printer in terms of layers. But one thing I'm worried about is the print bed is only supported at the back. If we put a little pressure at the front, it will drop. It also didn't come with a filament sensor or a bed leveling sensor. The retail price of this printer is $382, while the CR6SE is $399. The difference between them is less than $20, but the CR6SE came with a strain gauge bed leveling system and a filament sensor. In this video, I will try to spend less than $20 to add these two features to the printer. I will also print some free upgrades to make this printer work even better. First, we will take a look at the bed leveling system. The CR6SE uses a strain gauge instead of a BLTouch for auto bed leveling. Since our budget is only $20, we can't afford to add a BLTouch to this printer, as a BLTouch costs $40 to $50. So, I will try the 3D Touch to see how it works and see how accurate it is compared to the BLTouch and CR6SE strain gauge. The cost of the 3D Touch is super cheap. I found a seller on eBay selling it at $12.99, including free shipping. Since the seller is located in Los Angeles, it only took 3 days for me to receive the sensor. For the filament sensor, I got a pack of 2 from Amazon, and it only cost $11, which is $5.50 each. I will now install these 2 sensors to the Ender-5 Pro. First, we need to print 2 mounts to mount these sensors. For the filament sensor, I made a simple one. It's actually a remix from a cable clip designed by Matt448. I also uploaded this simple design on Thingiverse. If you are going to buy the same sensor, you can use this mount. My first print was not successful since the contact surface is so small. The stock magnetic bed can't stick to the PETG well enough. I changed the sticker sheet build surface to a PEI spring steel sheet, which is also from Creality. This print surface works extremely well with my other printers. This time the print is successful. Then, for the bed leveling sensor mount, I just searched for Ender-5 BLTouch Mount on Thingiverse. This design is from Sal Catropa, and I'm very sorry if I pronounced your name wrong. This design seems pretty nice. I think I need to bring down the sensor a little bit to make it work better. I have also remixed it and added 2.5mm in distance to make the sensor closer to the bed. I also uploaded it on Thingiverse. Next, we can open up the base. The filament sensor is quite straightforward. Just connect the cable to the E0 connector, which stands for Extruder 0. Then, put it between the extruder and the filament roll using the 3D printed mount. We will enable the filament sensor feature in Marlin when we compile the firmware later on. Now, we will install the 3D Touch. Attach the sensor to the mount with 2 M3 screws. You can add nuts to secure it or just screw it into the plastic. Then, wire the cable to the motherboard. Since the cable that came with the sensor is not long enough for the Ender-5, I will use some breadboard cables as an extension. There are 5 wires we need to connect. Let's start with the black and white wire. Use them to replace the Z-limit switch. Then we can connect these 3 wires. The red is 5 volts, the brown or the blue is ground, and finally, the yellow or orange is signal. You can see there is a 5-pin connector on the motherboard. We will connect the brown or blue to the first pin on the right, the red wire to the second, and the yellow and orange to the middle, and just leave the 2-pin on the left. Okay, the hardware installation is now done. I will keep the cover open to make sure everything is fine before I close it. Next, download the latest version of Marlin and compile our firmware. Normally, we can download an existing firmware from Creality. Go to Download and select Ender-5 Pro. There are a few different versions. Some older versions of the Ender-5 Pro may come with 8-bit boards. This printer came with a 32-bit board, which is V4.2.2. Okay, let's download this file. The files inside are duplicated. Inside this 4.2.2 motherboard folder, we have the same content, since we have a BLTouch and we don't need the adapter for older motherboards. We also have a filament sensor, but there is no such combination. Moreover, the Marlin is an older version of 2.0.1. In this case, we will go to the Marlin website and download the latest version so we can compile our own firmware, 2.0.7.2. After you extract the Marlin 2.0.x zip file, you will get this folder. Besides this folder, we also need to download the sample config files for the Ender-5 Pro. Unzip the file, go to Config, Examples, Creality Ender-5 Pro, and there are 2 folders inside. Creality is for 8-bit boards. Creality V427 is for the V4.2.7 motherboard, but for a V4.2.2 motherboard, we can simply copy the files inside V427 and do some changes, and go back to our Marlin firmware folder. Inside the Marlin subfolder, paste the files here and replace everything. In order to edit the files and compile the firmware, we need to install Visual Studio Code. Download the version that you need. In my case, I will download the Windows version. After you have downloaded and installed VS Code, you need to install an extension called Platform.io in order to compile the firmware. I already have it installed, but in case you are installing new VS Code, you can click Extensions, search for Platform.io IDE, and click Install. Now, the VS Code is ready. Select File, Open Folder, and select the Marlin folder. We need to change something in 2 files. They are located inside the Marlin subfolder. The first one is configuration.h, and the second one is configuration_adv.h. Since this config is for V427 motherboards and our version is V422, the pin may be slightly different. In this case, we need to go to configuration.h and search for motherboard. You can see the motherboard is now board_Creality_V427. We can right-click on this board and select Go to Declaration. You can see that besides this V427, there is another board called Creality_V4. We will use this board. Copy the name, go back to configuration.h and replace it. If you want to, you can change the machine name. For example, I will change it to Aurora Ender-5 Pro V422. Next, we will enable the filament sensor. It's also quite simple. You just need to uncomment a few lines of code inside the first file, configuration.h. 1. Search for define filament_runner_sensor. Uncomment to enable this line. 2. Search for define nozzle_park_feature. Uncomment to enable this line. 3. Inside the second file, configuration_adv.h. Search for define advanced_pause_feature. Uncomment to enable this line. Finally, we will enable the bed leveling sensor. Since the 3D Touch is a clone of the BLTouch, the settings are the exact same. Inside the first file, configuration.h, 1. Search for z-min probe uses z-min end stop pin. Make sure this line is enabled. 2. Search for define BLTouch. Also enable this line. 3. Search for define nozzle_to_probe_offset. We need to enter the distance between the pin of the sensor and our nozzle. Use a ruler to measure. For example, our pin is about 43 millimeters on the left. We will enter -43 for the first number, which is the X offset. We are about 10 millimeters in front of the nozzle, so the Y offset is -10. We can leave the Z offset as 0. We can use the paper test to find out the exact number when we turn on the printer. 4. Scroll down a little bit to define Z probe speed fast. Now it's using the homing speed. If we want to make it slower to get more accurate results, we can change it to parentheses homing_feed_rate_Z/2. For me, I normally won't do a second probe, but if you want, you can also enable multiple probing and extra probing to get even more accurate results. But usually, a slower probe works really well and doesn't take too much time. 5. Search for min_software_end stops. Comment out this line, as we want to disable the software end stop. That means we can move the Z-axis to a negative number when we want to adjust the Z offset. If this line is enabled, we cannot move it lower once the Z-axis reaches 0. 6. Search for define auto bed leveling by linear. There are 5 different types of bed leveling options. The first 4 are for auto leveling. From the simplest 3-point level to a unified leveling, I will choose bilinear as this is the most effective and common way. It allows us to use a grid like 4x4 or 5x5 to probe the bed, like 16 points or 25 points, or even more if you want. 7. Search for grid max points X. By default, the number is 3. Since the grid max point of Y is set to equal X, if we set it to 3, it will probe 3 by 3, which is 9 points. I normally do 16 points for a 235 by 235 bed, like the Ender-5 Pro or Ender-3. For larger beds like 300 by 300, I will use 5 by 5 to probe 25 points. 8. Search for define restore leveling after G28. By default, after we do auto home using G28, it will disable auto bed leveling, unless we run G29 or M420S1 to load the saved mesh from the EEPROM. If we enable this option, it will automatically load the saved value without putting M420S1 inside our G-code files. 9. We have the last line to enable in this file. Search for define z_safe_homing. This will make sure it will not probe outside the bed when we do homing. It will go to the center of the bed for auto home. We still need to enable one more option in the configuration_adv.h file. Search for define baby stepping. Enable this line. It will allow us to adjust the Z offsets real time when we are printing. Sometimes we may want to print different layer height. For example, by default, we will set the Z offset layer to 0.2 for each layer. If we want to print 0.3 or 0.4 layer height, we may need to adjust baby steps when we are printing the first layer to make sure it won't be too close to the bed and squeeze the filament too much. Okay, we are now ready to compile the firmware. Click on the alien head icon for the Platform I/O extension. Under Project Tasks, we need to select the processor chip on the motherboard. Scroll all the way down to STM32F103RET6 Creality. Select Build. You can see the terminal is showing the firmware is building. After a while, you will see this success message. We can then go back to our Marlin folder, .pio subfolder, build. You can see the last firmware that we compiled is here, with the file name firmware-year-month-day, followed by time.bin. We can copy this file to the root of your micro SD card. Turn on the printer and it will upload it to your printer. Now the firmware is updated. You can see the printer name has been changed. Next, we can do auto home and make sure the leveling sensor is working. Okay, it goes to the center and probes our bed for auto home instead of using the Z limit switch. You can remove the limit switch or just keep it here. We also need to set the Z offset to tell the printer the distance between the pin and the nozzle. We can move the Z axis down, keep it close to the bed and do the paper test. The perfect distance will be a piece of paper, which is about 0.2 millimeters, as we normally print at 0.2 layer height. In my case, the Z offset is negative 1.4 millimeters. Go to Control, select Z offset, adjust the number and save the value. Next, we will test the filament sensor. Before we feed in filament, we can poke a short piece of filament into it and try to print something. When it's ready to print, take away the filament and see if the printer pauses and shows us a filament runout message. This is also working fine. Before I do some test prints, I would like to test the accuracy of this 3D Touch. Since I have 4 printers with BLTouch installed, this is actually the first time that I will try this clone. I'm a little skeptical about how accurate this sensor will be. If you watch my previous videos, I did a test on the CR6SE strain gauge and compared it to a BLTouch. I used pronter face to collect some data and used Excel to do a standard deviation test. I came up with the accuracy of the BLTouch, which is 0.0055 millimeters, which is around 3% if we print at 0.2 layer height. The CR6SE strain gauge is 0.0078 millimeters, which is around 4%. It's not as good as the BLTouch, but there is no noticeable difference on the actual prints. We will do the same to the 3D Touch. Probe the bed 5 times, copy the data, set up some formulas in Excel. We came up with an accuracy of 0.01 millimeters, which is about 5% if we print at a 0.2 layer. The 3D Touch is the worst leveling system out of the three, but I still think it should work fine, as 5% of a 0.2 millimeter in the first layer is pretty much unnoticeable, unless you're trying to compare a 0.2 millimeter layer with a 0.19 millimeter layer under a microscope. Considering the price of this 3D Touch is just $13 with free shipping, that means the actual value of this sensor is less than $10. For this super cheap price, I am quite satisfied with this level of accuracy. Now, I will do some test prints with this new setup. The largest thing I'm going to print is a set of support mounts for the print bed, since it is only supported on one side. So, when we print something big and heavy, we can expect similar kinds of drops. It actually took me more than 10 hours to print this. I used 4 M3 screws and nuts on each side to mount it. Now it looks much better. Next, I will print a bed cable support. I'm a little worried that the wires will break over time, so this cable strain relief from grizzlyeric is perfect. Finally, I will print a cover to hide the cables from the base. Now, the printer looks much nicer. That's it for this video. I hope you liked the upgrades I added to this Ender-5 Pro. I'm going to review another printer next week. It's a Core XY printer. After comparing a few choices, I finally chose the 2 Trees Sapphire Plus. I bought it at an amazingly low price. This printer requires a little more time to build compared to the Ender-5 Pro. I will show you the assembly process and review this printer next week. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you will see something new. I will see you next week.